For those of you who have joined us, we're going to go ahead and get started. Welcome to the AVL and Rescale webinar showing how to run AVL Excite in the cloud. First, I'll do some quick introductions. I'm Sarah Dietz. I'm the Business Development Manager here at Rescale. Following my quick presentation, I'll be passing this over to Brett Sheets with AVL. He's a support manager. And then we'll come back to Mulyanto with Rescale. He's the VP of Engineering. We're going to get started. A few housekeeping items. We are recording and we'll be distributing this webinar later this week. If you have any questions during the webinar, please make sure to type them into the questions section of the GoToWebinar panel, and we'll answer these at the end. Here's our plan for today. I'll do a quick overview of Rescale's platform and the AVL Rescale partnership. I'll then pass this over to Brett, who will talk about AVL, AVL Excite, as well as the model we'll be looking at today. Finally, Mulyanto will show a demo running AVL Excite on the Rescale platform. To start, a bit about Rescale. Rescale provides a unified cloud HPC platform for running simulations. This platform was built to allow engineers and scientists to easily set up and run different types of simulations with a straightforward, easy-to-use interface. Rescale is a multi-cloud environment, and we've partnered with multiple infrastructure providers with over 30 data centers globally, allowing our users to leverage a wide range of different types of hardware, including InfiniBand and GPUs. Users can monitor their progress in real time, and our admin portal allows IT and management to manage and track usage, as well as set additional controls. Rescale's platform can also integrate with existing on-premise resources, so IT and management can have transparency and control over the resources being utilized through one comprehensive environment. At Rescale, security is our top priority. We go to great lengths to ensure that the platform is secure and that our users' information is secure at every stage. We go through lengthy and in-depth processes to meet strict security compliance and regulation requirements. Users' data is encrypted both at rest and in transit, and when simulations are running, they're being run on isolated encrypted clusters. We're happy to talk offline in more detail about the different security measures we have in place. Now to jump to the partnership. We have a strong strategic relationship with AVL. For AVL Excite in particular, this partnership enables Excite users to run their existing licenses on the Rescale platform to leverage Rescale's wide range of on-demand hardware to scale out and accelerate their workflow. As mentioned, Rescale's platform is available globally. In addition to this worldwide range of data centers, we have dedicated regional sites in both Europe and Japan for users who need their data to stay within one region. We want to also note that in addition to AVL Excite, we also support AVL Fire. AVL Fire is available with on-demand licensing through the Rescale platform. We also had a webinar 2 weeks ago and recorded this, so we're able to provide you with a webinar showing how to run AVL Fire on demand as well. I'm now going to be passing this over to Brett, who will be presenting on AVL. Brett?
Yes.
Okay.
Sorry. Let's see. Hello, everybody. Show my screen. Can you confirm it's visible?
Yep.
All right, thank you. Yes, my name is Brett Sheets. I'm located in Plymouth, Michigan. I'm going to show a little bit about the AVL background to give you an idea. We're a 65-year-old company that's focusing mainly on powertrains, global company that's doing about $1 billion in sales globally. We have 3 main units at AVL that are all related into to powertrains. We have powertrain engineering, we have development platforms for doing testing, and the group that I'm with is a simulation technologies group. And in the simulation technologies group, we have a process optimized tools for doing virtual engine simulation. combustion, as just mentioned, with AVL Fire, which is available on the platform, and structural analysis, mechanical analysis with our Excite products. The suite of tools that AVL has ranges from 1D to 3D fluids, vehicle simulation, Excite Power Unit, which is used for durability and MVH, and as I mentioned previously, fire. The Excite tool has many applications ranging from durability and strength analysis of components to elastic hydrodynamic contact analysis, where we investigate friction, wear, and failure mechanisms in slider bearings, and then noise, vibration, and harshness, looking at the system dynamics for acoustics in engines, transmissions, and drive lines. The tools for the virtual concept allow us to go from concept analysis, where we lay out the engine, look at upfront designs to size the engine, then use tools for doing dynamics such as crankshaft, torque vibrations, valve trains, integrated valve trains with the crankshaft, and as I mentioned, slider lubrication for bearings and looking at failure mechanisms. And a hot topic these days is also friction for fuel consumption, and this is also linked to our vehicle simulation cruise. Durability from a strength analysis point of view for various components, and as I mentioned, NVH for transmissions and drive lines. Just a few pictures here. This is what Excite Power Unit is capable of doing. It's a flexible multi-body system based upon finite elements. And in this particular example, we're simulating an inline-4 engine, which is what we'll be submitting later today on the cluster. But here we're seeing the stresses in a crankshaft as it occurs over an engine cycle. The actual model that we have loaded up is capable of solving, in addition to the dynamics, the hydrodynamics that are occurring at the slider bearings due to the loadings that are occurring from the combustion simulation. This types of simulations can then lead to doing MVH and acoustics, where we look at the radiated noise off of the engine and predict it to sound power or to microphone locations for drive-by and so forth. And included in Excite is also the capability of doing gear contact, which is a main source of rattle and whine that you would have in a transmission. Not only is Excite able to use for engines and powertrains, but it can be expanded to other multi-body dynamic systems, including wind turbines, pumps, hydraulic actuators, and so forth. So it can be taken beyond. What's happening at the fundamental level with Excite is it's using elastic bodies predominantly that are coming from finite element condensations, either using Nastran or Abacus, and then connecting those up to the bodies through various joints. These joints can be simple nonlinear bearings or complex hydrodynamic joints for looking at the oil film thickness and mixed lubrication. The system is excited by transient forces. These external forces predominantly are the cylinder pressures that are either pre-calculated with AVL tools or can be measured from test data. And then from these external excitations, we're able to solve systems that have a reduced set of degrees of freedom, generally in the range of 500 to 5,000 degrees of freedom, all starting from models that can be upwards of 5 million degrees of freedom prior to the condensation process. The actual model that's been submitted for just demonstration purposes is, this is an inline-4 engine that comes with our installation. It comprises of a flexible crankshaft that's connected to the engine block that's flexible through 5 main bearings that are being solved with hydrodynamics. The forcing function is the cylinder pressures coming in and acting on the con rods and piston that are connected through nonlinear springs to the crankshaft. The whole system itself is supported by engine mounts onto a rigid chassis. In the 3D view, here's the finite element model of the engine prior to the condensation. Once the engine's condensed, for example, we are able to have nodes that are used for connections between the bodies. So, for example, we have nodes here on the cylinder liner that are connected to the piston and connecting rod. We have nodes that are on the main bearing shell that allow us to connect the crankshaft to the block with hydrodynamics. The blocks, the components themselves, you end up defining what types of bodies they are and then where the finite element condensations are provided. You do this for the various bodies and then connect them up through the joints. And here would be a typical setting for a bearing connection where we'd specify the width and diameter and clearance and also the hydrodynamic properties such as the oil type and temperature. From that, you would package up the models and then send them to Rescale, unpackage them at Rescale, and Leonto will show you how to submit it from there. I'd just like to say that we have two support engineers here in the U.S., myself and Brian McCaskey. So if after this presentation you have any questions, you can contact us via email at excitesupport@avl.com. With that, I'll pass it back to Leonto, and he'll show us how to submit the jobs.
Thanks, Brett. I'm going to make
control.
Leonto the presenter right now.
All right. You're welcome.
All right, thank you, Brett. So I'm just going to real quickly show how to run the model that Brett just talked about on Rescale. So when you come to Rescale, you're presented with this login page. For our login, we support both single sign-on as well as multi-factor authentication. So I'm just going to log in to my account right now. And so once you're logged in, you will be presented with this page here, which shows a list of jobs that you are currently running or have run before. So as you can see, I've got one job that is running, and I've got 3 jobs that I have ran before that I've completed. So to start off with setting up your AVL Excite job, we are going to just go to New Job here at the top left, which will bring you to the job setup page. And the first part that you will have to do is upload the input files for the job. So what I have here on my desktop is the input files here. So I've got the Excite directory here, the FEM and the SHM directory. What I did is
it's not visible.
Is my screen not visible?
Yeah.
Oh, there it is. Thank you. I'm sorry. My fault.
So what I've done is I've zipped up the directory into one zip file, which makes it easier to upload to Rescale. And if you go into the Excite directory here, you can see that we have 4 speed cases here, 1500 RPM to 4000 RPM. So I'm going to go back to Rescale now, and I'm going to upload my input file. Here we go. And so on the top here, you can see the status of the upload. And while the file is uploading, we can go ahead and continue setting up our job. I'm just going to give this file a name. So I give it a name first, and then the next step what we're going to do is select the software that we're going to use. So we're going to go to the software setup selection page by clicking software here at the top, and I can go ahead and search for Excite, and then select Excite. I've automatically selected the latest version, 2014.1, and then I have to specify the command to use to run Excite. We can run a single case of the input file that I just uploaded. So we can, for example, run 1500 RPM here, which will just run the 1500 RPM case. If I would change this to 4000 RPM, it would run the 4000 RPM case. But in this case, I'm just going to run all the runs in succession and by not specifying any run at all. So this excite command is a script that we have written at Rescale, which allows easy execution of AVL excite on Rescale. The second thing you have to set up is the licensing options. Currently, AVL excite is available with on-demand. With bring your own licenses only. So to specify your own license file, you can specify your license server here. For example, 107000 license server. In my case, I will use the Rescale license that we have available here in-house. The last step that you have to set up is the hardware that you're going to run on. AVL Excite is a multi-threaded application, so we can run it on multiple cores. In this case, let's use 8 cores. I chose nickel here as the hardware, the core type to use for this job, but we have many other hardware profiles available, including Onyx, which has the latest Haswell processor, as well as GPUs and InfiniBand core types. On the right side here is an overview of the hardware you've selected. As you can see, I selected 8 cores on a single server. It also shows you how much memory and how much disk space you will have available on the hardware that you're going to provision. So we've done everything we need to do to set up the job. Just to recap real quickly, we uploaded our input file. We selected our software, specified the command to use to run the software, and selected our licenses. And then we specified what hardware we're going to use. So now we're ready to submit our job. And so I'm just going to click submit here in the top right. And this will bring us to the status page. So on the status page, you'll be presented with the status of the cluster and your job. Right now we're still validating input. And after validating, we're going to start the cluster, provision the hardware, after which it will automatically switch to running your job. In the top right here, There's also two buttons that I would like to talk about right now. The first one is the sharing option. This will allow you to share your job with either AVL support, Rescale support, or with your colleagues inside your company. For example, I can share this with Sarah and leave a message. And so this is now shared with Sarah. The other option we have here is the cloning option. And this allows you to clone an exact copy of the current setup of your job. So what I'm going to do right now is clone this job. And while we're waiting for the other job to start, I'm really quickly going to show how to run a RPM parameter sweep using our DOE framework. So AVL Excite is usually run using RPM parameter sweep, and Rescale's platform is perfect for running these kinds of sweeps and running the runs in parallel. So what I'm going to do right now is, first of all, I'm just going to change the name of this job to RPM sweep. On the top right here, I'm going to change my job type to DOE. Yes. And this will allow me to set up my parameter sweep. So I already have my input file selected because I just cloned my previous job. The next thing I need to do is set up my parallel settings. I can either specify my variables using minimum and maximum value and an increment, or I can upload a CSV file which has the definitions of the runs inside of it. In this case, I'm going to upload a CSV file with the runs. And in this case, it's called runs.csv. And this file will looks like this. It has the name of my variable and the values that I want to run. So the run variable will have 1500 RPM, 2000 RPM, 3000 RPM, and 4000 RPM. The next thing I need to do is upload a template. This template will be populated with the run variables. In this case, the template is a script. And the script contains the commands that I want to run. So in this case, it contains the excite-r and then the run variable. This is the command that I talked about in my previous job setup. The last thing I need to do is give a name to my populated template, and we'll just call it run excite. And lastly, we have to actually call run excite from the command line here. So in this case, we'll actually run the script, which is the populated template. So the nice thing about using this framework is that we now can actually select multiple slots to run in parallel. So in this case, since we have 4 runs, I will run 4 slots in parallel. So I'm just going to submit this job. And so instead of waiting for this cluster to start, I am going to go to a job that I launched before. And you can see here that that you can look at all the files that are on the cluster. For example, you can look at the log, which shows the log for the specific run, which is 1500 RPM. And you can, for example, also look at the simulation.out log, which is the direct output of the excite process. These logs get updated every 5 seconds, so you just hard update. Alternatively, you can just download these files as well by clicking the download button here. The last thing that I want to show you is what a finished job looks like. So let's go to a RPM sweep finished job. In this case, you can see we had 4 runs. And you can see the run number here, or the RPM number. And if we drill down into these runs, you can see all the files associated with this run. You can look at individual files. For example, we can look at all the .out files. In this case, we can just download these files individually, or you can select all the files, for example, and go to Actions and download the selected files, which will download all the files that you've selected. Alternatively, you can click Download all the files for this run, and that will download all the 3,000 files that are associated with, or 2,800 files that are associated with this run. So that concludes the demo. I hope I was able to give an overview of how easy it is to run these AVL excite jobs on Rescale.
Thank you, Moyanto. I will take the screen back. So just as a final note here on the UI and workflow, we've also built in an administration portal that adds another layer of security and control here. This allows IT and management to track usage, set budgets, monitor and set software and hardware restrictions, and manage different user permissions. So it's just another layer on top here, and this is available on the platform as well. So this concludes the presentation. We have a little bit of time left for questions, and some people have written a few in. So the first question we received is how to connect to your license. How can you run your existing licenses on Rescale? And we didn't go into this too much on the during the demo, but there are a few different options here to connect to your licenses. Most commonly, our users opt to set up an SSH tunnel to their license server. We can also do a VPN. Users can opt to just open ports in their firewall as well. We do have documentation around how you can set up this connection that I am happy to send anyone interested. And we can also set up a call with your IT and our technical team to walk you through this setup. Another question is, if we want to run specifically in Europe, how can we determine that our data is running there? We have, as I mentioned, we have 2 other specific platforms other than running on platform.rescale.com. For the Europe platform, you would go to eu.rescale.com, and the interface is the same. You would just sign up for an account on that platform, and your data will run and be stored in Europe. We do have a couple other questions, but for the sake of time, I'm going to answer these offline. I'll be sending you emails directly. I want to thank Brett again and Moyanto for participating today, and thank you all for attending. We hope that this was informative, and we'll be as I mentioned, we'll be sending this out again. Hope you all have a great day. Thank you.